Hello everyone. So we are back to the design series and today we are going to see the template design pattern. It is one of the most simplest design patterns. So it is a behavioral design pattern. It lets you define a skeleton of an algorithm, but the subclasses can redefine certain steps of the algorithm without changing the overall structure. So the definition is pretty much clear. Let us try to have an example of a data parsing system and see how it is actually implemented. So it just says that the skeleton of the algorithm remains the same. It means how it does the work will remain always the same, whereas certain parts of that algorithm can be kept to override in the subclasses. So let us try to code it up. So template.cpp hash include iostream using namespace std. Now I would say the first thing I need an abstract class of a data parsing system. So why abstract? Because we just read the definition that some part of the algorithm will be kept to override. So we just need a few methods which will be overridden in the subclasses, whereas rest of the methods and functions will be completed. So class data parser, let us say. Now in the data parser in the public section, we need a skeleton of the algorithm. So void say parse data, someone will call this method and will pass a string. It is say a kind of file name. So inside this, there are certain predefined ways to do that. There is a predefined way to do this. Say you are going to open the file first and you will pass the file name. Once this is done, after that you're going to read the data. Now, after reading the data, you're going to parse it. Parse content. After parsing the content, we are going to close file. Right. These steps are predefined basically. So now we'll be having, say, a virtual destructor as well. Data parse. This was in the public section. After this, I can say in the protected section, I can define this method because I just need the base class to override this. Void open file const string ampersand file name. Inside the file name, I'll just log out something. Opening file, file name, handle. After this, I need the read data, which will see out reading data from file name. We should give a space over here. File name uh, seems to be correct. So we'll see. Okay, the file name should be a member of the class. So we were going to write it down at the bottom. So we'll complete that later on. After this, I would need a void uh, we need a close file first. We'll implement it, and later we need a parse file. So close file, cout closing file handle. After this, I need a virtual void parse intent method, and we are making it pure virtual so that other classes can override it. So inside this, we also need the file name. So we'll define it over here. Say string file name, and when we are inside the parser, we are going to say this file name equals to, or we could use initializer list file name, right? So by this, we are going to assign the values. Okay, initializer list cannot be used because this is not a constructor basically. It is a method. So we are straight away going to assign it the file name equals to file name. Now, after this, we are going to have multiple kinds of parser. So we can create different classes for them. Say there will be a concrete class, say JSON parser. A JSON parser will be publicly implementing the data parser. Inside the data parser and inside it, inside the protected section, we are going to have void parse content, and we're going to have the parse content method. Yeah, the spelling is same. So cout, we have parsing, say, JSON data. We'll log something out over here. After this, we'll be having a class for XML, let us say, or CSV, either of them, say XML parser, which will implement publicly the data parser, public void parse content, cout parsing XML data. Now, after this, let us see how we can make use of these classes inside the main method. Int main data parser. Let us first make it of JSON parser equals to new JSON parser. After this, I can call the parse data method, JSON parser dot parse data, and I can pass a data dot JSON file, and it will parse the data based on the structure that was already there in the abstract class. And for the parse content, it is going to take the method for the JSON parsing, which is parse content in the JSON parser class. Now, in the same way, you can also call the XML parser, pointer XML parser equals to new XML parser, and then we are going to call XML parsers parse data, return 0, and we should also pass some file over here, say data.xml. And let us try to run if we have any errors. G++, template dash O, temp. It compiled successfully. There are no errors. Temp.exe. And you can see, first of all, opening the data.json, then reading the file, then parsing the JSON file, and then close it. After that, XML file is opened and parsed in the same format. So the structure or the skeleton of the algorithm is same, whereas the parsing method is different, which is defined in the subclasses. That is the way how we implement the template design pattern. So we'll be coming up with more design patterns, and we are almost at the end of this series, and we'll see the good the we'll see some of the